Okay, with doing this one, so in order to find any eigenvalues, I have to make this equation. I subtract lambda from it, 1 minus a, and then 1 minus b minus lambda. And I want the determinant of that matrix to be 0. And so I'm just going to do some algebra now. So a minus lambda times 1 minus b minus lambda minus 1 minus a times b is 0. And I'm going to work through it. So I get a minus ab minus a lambda and minus lambda plus lambda b plus lambda squared minus b plus ab equals 0. That cancels, and if I rewrite this, I get a lambda squared, I get a plus lambda, and then I have a b, a minus a, and a minus 1. And so that was these terms, that one's done, and then I get a plus an a minus b equals 0. So we're asked to show that lambda equals 1 is an eigenvalue. Well, if I plug 1 in there, I get 1 squared plus 1 times b minus a minus 1 plus a minus b, which is 1 plus b minus a minus 1 plus a minus b, which I can see the b's cancel, the a's cancel, the 1's cancel, equals 0, therefore eigenvalue. So continuing, I need to take this equation here, this one here, this is my characteristic polynomial. I know that one of the eigenvalues already is 1, so I know it's going to factor the lambda minus 1, and then I just have to basically deconstruct that scenario. I know that two values have to multiply to get a minus b, and so this has to be a minus b. I'm thinking about my positives and negatives. If I want to get a positive a minus b, I need to make this a negative. So it's going to be lambda in this scenario, and that equals 0. And so I know lambda is 1, so lambda minus a minus b equals 0. So lambda will be a minus b is my second eigenvalue. So now if we are asked, we go back to the question to the eigenvectors. So I'm going to go back to this particular matrix is alpha minus a minus alpha. So if lambda is 1, then the matrix is a minus 1, b, 1 minus a, and then 1 minus b minus 1. This, when multiplied times xy, has to be 0, 0. So when I simplify that, the top line gives me a minus 1 x plus b equals 0. The bottom line gives me 1 minus a x. Those cancel, and I get minus b y equals 0. Now, a nice check that you should always consider is that this line and this line are the same with the exception of a factor of a negative. So that means I've done everything correctly. And so now if I take this particular one, I get, by equals 1 minus a x, because I switched the signs around. Dividing by b, y will be 1 minus a over b x. So the vector, if I let x be b, y will be 1 minus a. This is one of my eigenvectors for lambda equal 1. If I go to the other scenario, I will take this particular eigenvalue and I'm going to plug it into the matrix. So it's going to be a minus b, and then 1 minus a, and 1 minus b minus a minus b. And this times xy will be 0, 0. Do some simplifying here. I get minus b minus b, 1 minus a, the b's cancel and I get 1 minus a times x, y equals 0, 0. And so again, I can see, oh, hold on, careful, that should be a plus. So I just did a check to see if these two lines were scalar multiples. That's why I noticed there was a careless mistake with my negative. So I can say that bx plus by is 0. I'm not even going to worry about the second line. And so I know by equals minus bx, so y is equal to negative x. If I make x equal to 1, to positive 1, y is negative 1. And so this is the other eigenvalue. Hopefully that helps. So eigenvector.